There's no products yet. So there's nothing for the reverse reaction to take place with. So I'm going to scoop them over. Okay, this pouring represented reactants turning into products and products turning into reactants.
You can see the concentration of the products has increased. So when I scoop this time, okay, I'm getting some products changing into reactants. Notice what happened to the amount in this beaker. Did it go up or down? It went down. Why would it go down? The concentration of my reactants is decreasing, so the rate is decreasing. So I pour. The rate of the forward reaction is decreasing, while the rate of the reverse reaction is increasing. Okay? So again, notice the reverse reaction is speeding up. It's getting fuller and fuller beaker. This one is continuing to go down a little bit. It's going down slowly. Okay, notice again the forward reaction is starting to drop. The reverse reaction rate continues to speed up. But what's going to happen is that we're going to get to a point after we let this reaction go for a little bit where these two beakers essentially are holding the same volume. So, we look at the concentrations here.
Of the liquid inside here represents the concentration. The more stuff in the beaker, the greater the concentration, because remember these are in the same physical volume. So the concentration of the products has increased, the concentration of the reactants has decreased. If I look at my forward reaction, remember this beaker represents my forward reaction rate. If I look at the amount of, and then I do this, remember this little beaker represents the reverse reaction rate. Okay? They are starting to get closer together. So we're going to scoop again. And now let's measure. Okay? So you can see that those two levels are about the same. Okay? We're going to call this essentially at equilibrium. Okay? Now I can pour these over, and I can continue to do this. I can continue to have this reaction take place. This is what happens in an equilibrium, right? I continue to dump. And again, to within the error of my measurement, those are basically the same level. My scooping isn't perfect. This is a simulation, right? And I can keep pouring as long as I want. They're going to continue to be at the same level because the rate at which I'm transferring from one to the other is the